Dear students, I welcome you to this class, and in this class we will learn or we will recapitulate our previous knowledge in calculus. For example, we will just recapitulate our previous knowledge on function, then plotting of functions. After that, so continuity, differentiation, and then plotting of curves, approximation, Taylor series, binomial series, etc. So these are the basics or preliminaries to know calculus, and we have learned all about that, all about these topics. And in this series of classes, we will just recapitulate and will apply to solve some problems. So first of all, this is the first class, and in this class we will learn or we will recapitulate plotting of functions and then limits. So let us start. First, we have to know what is a function. So if you have given a variable y which depends on x, and the value of y is unique for a certain value of x, that is the function y. If the function y has a unique value for a given value of x, then the variable y is said to be a function of the variable x. So it is not very difficult to understand in this case that the variable y is the dependent variable and x is the independent variable. So to represent a function, you need to have a dependent variable and an independent variable. So you can mathematically represent a function that is y as a function of x in this way. That is y is equal to function of x, and the variable x is as I already told, that it is the independent variable, and y is the dependent variable, and the set of all allowed values of x is called the domain of the function, and the values of y for the corresponding values of x in the domain is called the range of the function. So this is the very basics of function, that is you need to know to study. And if you wish to desire to study the function, then you need to know the dependent variable and independent variable, and the range of the domain of the independent variable, and range of the domain, dependent variable. So now come to the next topic, that is plotting of graphs of the function. So it is very important to plot a function, and with that you can understand, you have the complete knowledge of that function. So let us first, we wish to plot a function that is y is equal to fx. So to do this, we draw two Cartesian. We used Cartesian coordinates, that is ox and oy, which meets at the point O, that is intersect at the point O. Now let us that x varies in the x direction, that is in this direction, and y varies in this direction, and here for each value of x, corresponding value of x, the value of y, that is fx, should be presented in this graph in the y direction. Let us consider that for a certain value of x, that is OQ, that value of x is OQ, the value of y in that case, that becomes OR, that is to up to this point. This point is R, say. So for the value of x, for the value of x as OQ, the value of y becomes O. This point is R, OR. So if you write these at the point P, then this OQ is X and this OY is Y. So this point will be PXY. So this is the simple plotting of this function, that is y is equal to fx, that is dealt here. Just go through these lines. Now you should note that any line parallel to y-axis, if any line parallel to y-axis cuts the graph more than one point, then the it should not be a function. So just to remember it, you plot the given identity inequality, that is it, you can say it as inequality y is equal to fx, this, and if after plotting these line or any line, if you draw any line parallel to this y-axis and it cuts the graph uh, 1 point more than 1 point, then it should not be a function. So here are some examples. Here is a graph and here is another graph. X is plotted in the x direction and y is plotted in the y direction. So here y is equal to fx is a function, but it cannot be said at a glance that it is a function. So now you draw another straight line parallel to the y-axis that will done here, that has done here. So this line cuts this graph in 2 points. This is number one and this is number two. So it cuts the graph more than 1 point. So it is not a function. In this case, y is equal to fx cannot be y cannot be represented as y is equal to fx. Similarly, for this case, for this graph, you have drawn another straight line parallel to y-axis, and it also cuts the graph in 2 points. So it is not, in this case also the graph does not represent a function. So now come to the another one, that is plot of graph y is equal to x. So here is the equation y is equal to x. You can compare it with the general equation of a straight line, that is y equal to mx plus c, and comparing this you can easily understand that c is equal to 0 in this case, and that means it would be a straight line but passing through the origin, that is this that is shown here. And also from this relation you can understand that m is equal to 1, that is the tangent of the graph is equal to 1, that means theta is equal to pi by 2. That means this straight line will subtend an angle, will make an angle with the axis with the value of 45 degree, because pi by 2 is 45 degree, pi by 4 is 45 degree. So this is the plotting of these equation, that is this function, the function of a, the function of y, which is nothing but a function of x. Now another one is for in liquids, the pressure variation with the depth h is given by the formula P is equal to P0 rho gh, where rho 0 is the atmospheric pressure, P0 is the atmospheric pressure and rho is the density of the liquid. And draw the graph, and just you write this equation, that is P is equal to P0 plus rho gh, and in this case this P should be plotted against this h, because P0 is a constant, and just compare this equation with the general formula of the straight line, that is y equal to mx plus c, and from here you can easily understand that c is equal to P0, that means at x is equal to 0, at x is equal to 0, p has certain value, that is P0, and obviously in this case it would be a straight line but not will be passing through the origin, and that is here at 0 it is P0. And after that, if you if you have some values of x, or for values of h, sorry, for values of h, P0 will increase with the increasing value of h, that is there. So this is the straight line. So this is not, this will actually represent a straight line but will be not passing through the origin, but it cuts the origin at P0, cuts the y-axis at P0. Okay, now plotting of a parabola. So plotting of a parabola, you know the general formula of a parabola is equal to y is equal to ax square plus bx plus c, where a, b, c all are constants. Now if a is positive, then the parabola will be open upwards. That means in this way, in this, it will be in this way. Okay, so open upwards, and if a is negative, then the parabola opens downward. That means in this way, in this way. Okay, just see here, in this way. If a is negative, then it will be in this way. That means it will be it will open downward. Now the equation, the parabola equation, if you write in this pattern, that is y minus k whole square is equal to c into x minus alpha, or x minus alpha whole square is equal to c into y minus k, then from this form of the equation, you can and you can calculate the vertex of the parabola, and which can be found out from the relation that this y minus k, that is equal to 0, or from here y is equal to k, and from here x minus alpha is equal to 0, or x is equal to alpha. but just equate this to 0 and this to 0. From here you can find out the value of k and alpha, which are the vertex of the parabola. And this will be very clear from the next from the example that are discussed here. So number one example is plot the graph y is equal to x square minus 4x minus 5. So this is the given equation. I am rewriting this here, and you know the general formula of the parabola is given by y is equal to ax square plus bx plus c, and from here just compare these two equations, and it is easily understandable, or it is noticeable from here that a is plus 1, that means a is positive, so the parabola will be open upward. So this will be in this fashion, and also from here just you put y is equal to 0 in this expression. So why you should use y is equal to 0? So you, if you wish to find out the intercept on the x-axis, intercepts of the x-axis, that means in that case y should be 0. So to find out the intercepts on the x-axis, you need to equate y is equal to 0, because in this case y value is 0. So from this expression x square minus 4x minus 5 is equal to 0, just factorize it, it will give you x minus 2 whole square minus 9 is equal to 0, and from here x minus 2 is equal to plus minus 3, that means x is equal to 5 and minus 1. At these 2 points the graph cut or intercepts the x-axis. So now the given equation, this equation can also be written in this form, that is here. So you know that I have actually written this term as this in this form. So this is nothing but y. So y can also be written as there in this way. That's y is equal to x minus 2 whole square minus 9. And from here you can also write x minus 2 square, that is equal to y plus 9. So this has the form, right? See here, this has the form like this. This is the form like this: x minus alpha whole square is equal to c into y minus k. So in this case alpha is equal to, so that is here x minus alpha whole square is equal to y minus k. So here alpha is equal to 2, and that means you need to alpha is equal to 2, and your beta, that is alpha and k, sorry, k is equal to minus 9. So now you need to compare these x minus, here x minus 2 is equal to 0, x is equal to 2, and y plus 9 is equal to 0, or y is equal to minus 9. That means in this case the vertex will be 2 and this minus 9. So here it is plotted here. So intercepts are minus 1 and then minus 5, these are here, and the vertex is 2 and minus 9. So graph is drawn here, and this graph is x square minus 4x minus 5 is equal to y. So next another one example is here, y is equal to x square, and in the similar way that you have employed in this case, the similar process method technique you should use in this case also. And this equation, and here see here that in this case a is equal to 1, so it will be open upward, and this can also be written as x minus 0 whole square, that is equal to y minus 0, and from here you can find out the vertex, that is from here 0 and from here 0. So 0 0 is the vertex, and this is the graph. And plot of y is equal to mod x. So you know that y should be y is equal to x, y would be equal to x when x is greater than 0, and it is negative minus x, it is y is equal to minus x when x is less than 0. You know it, you know it is okay. So now for the first case, this is a straight line whose tangent is 1, and it will be passing through the origin, that is done here, that is, and in this case tangent is 1, that means theta is equal to pi by 4, that is 45 degree. And the similar way this is another one, and this case x is negative, and in this case it is also a straight line passing through the origin, and in this case also tangent is pi by tangent is minus 1, and from here theta is equal to the angle which makes it with the x-axis or the axis, since these two angles are equal, so this is 45 degree. So now this is the plot of the graph. Now graph of exponential function. So you have a function which consists of exponential. of x. So that is here y is equal to x is greater than 0, and it is called an exponential function, and you need or you have to now plot this function in a graph, on a graph. So that to do that, you see here from here for as x increases, then from this relation you can understand that y is increases, and in this case y actually increases monotonically. So that in that sense, this function y is called a monotonically increasing function, and it can be made as large as possible by taking large values of x. Now for x is equal to 0, you can understand from this relation y is equal to e to the power 0, that is equal to 1, and that will be on the graph. And after this, so therefore, since y is equal to 1 for x equal to 0, so 0 1, that point is, what is that point? That point is 0 and 1, and that should be on the graph. That is here 0 and 1, this point is here. And however, for negative values of y, negative values of x, y is equal to a to the power minus x. That is 1 by a to the minus x. And in this case, as in x is increases, y is decreases. That is in this case, y decreases monotonically. So now we should consider two cases. One case is first case. The first case was a greater than 1. So the graph is here. And for a less than 1, in that case y equal to fx, that is a to the power x, and for a positive value of x, it has small values, because in this case is your less than 1. So small values, because a is, since a is less than 1, so a to the power x should be very small quantity. So that's why that's why for positive values of x, it has small values that are represented here, see here. And for however, in the case of negative values of x, it will be higher, because in this case 1 by a to the minus x, and a is a very small quantity, so this will be the value of a to the power. So here is written, so it is written mistake, it is, here is an error. It would be 1 by a to the power minus x, not minus x, a to the power x, sorry, it would be a to the power x. So in this case, if x has large value, so then why should be increasing monotonically? So that is here presented here. Now logarithmic function, you know that if x is equal to log a, this type of equation is logarithmic function. And here if x greater than 0 and x less than x greater than 0 and a greater than 0, these two conditions can be considered. And for a greater than 0, as x varies 0 to infinity, y will increase monotonically from minus infinity to plus infinity. That is here represented here. And for a less than 1, the function decreases monotonically. That is also shown here. Just go through this. And graph of trigonometric functions, for example, first one is y is equal to sine x. And for to plot y is equal to sine x, you know that for x is equal to 0, y is equal to 0. And for x is equal to pi by 2, y is equal to, say, it is 1. And for x is equal to 3 pi by 2, it is again minus 1. In the reverse direction, that is in case of the negative values of x, if you use the value x as minus pi by 2, then the y has the, that is sine x, has the value minus 1. And then if it is 3 pi by 2, that is x is 3 pi by 2, then it has the value plus 1. So this is the graph. Just connect these points. Just connect the point. This is the graph of sine x, and now graph of cos x, that is here. You know, in the case of cos x, the graph of cos x can be calculated in the similar way that we adopted here, similar method that we adopted in this case. So that should be here. This is the graph of cos x, and you know that for 0 it is plus 1, for pi by 2 it is 0, and for pi it is minus 1. Again, for the negative values of x, for minus pi by 2 it is 0, and for minus pi it is minus 1. So this is the graph. Now graph of y is equal to tan x, and y is equal to tan x is defined all values except x is equal to 2n plus 1 into pi by 2, because in this case, for you can write tan x is equal to sin x by cos x, and cos x for the integral values of pi by 2 is 0. So in that case, tan x should not be cannot be defined. So tan x is not defined for the values of 2n plus 1 pi by 2. For the value x is equal to 2n plus 1 into pi by 2, where n is an integer, any integer. Okay. and it has the value of tan x, that is y, increases from minus infinity to plus infinity x, as x increases from minus pi by 2 to plus pi by 2. So this is from, it is increases from, this is minus infinity, and it increases in this way, and it goes to plus infinity from minus pi by 2 to plus pi by 2. And from this section also, pi by 2 to 3 pi by 2, the similar event happens, and here also. So this is the graph of y is equal to tan x. Now the graph of cot x, that is also represented here, and this is the graph of, and just go through this, these lines, and you will understand the nature of y is equal to cot x here also, that is presented here also. And I am not going to the details of these graphs also. The graph of sec x is here also, and the graph of cosec x is here also. So I am not going to details with these graphs, just you try to plot this, and using different values of y corresponding to x, and these are here and here. So this is cosec x. So now come to another one, plotting of graph sine inverse x. So you know that if you have the value x is equal to 0, then y should be sine inverse 0. That means sine inverse 0, that means you should have y is equal to 0 also. So that is here, x is equal to 0, y is equal to 0. X is plotted here and y is plotted in this direction. So 0, 0 is here for x is equal to 0. Now if x is equal to plus 1, then y is equal to y should be what? Y should be sine inverse 1, that is equal to pi by 2. So at plus 1, y is equal to pi by 2 is here. And in a similar way, for x is equal to minus 1, y is equal to y should be calculated. Y in the that y is equal to minus pi by 2, that is here. Minus pi by 2, that is here. So just connect. This is the graph of sine inverse. So y is equal to sine inverse x. Now cos inverse x, that is here. The cos inverse x is also computed or plotted in the same way. For x is equal to 0, you know, x is equal to 0, y is equal to cos inverse 0, that is pi by 2. That is pi by 2 is here. So at x is equal to 0, y is pi by 2. And for plus 1 or plus 1, x is equal to plus 1, then y should be y, that is equal to cos inverse x, should be your 0, that is here. And for y is equal to minus 1, it should be pi, minus pi, that is here. So just connect this. This is sorry, pi. It should be pi. So that is here. This is the graph of cos inverse x. Now tan inverse x, the graph y is equal to tan inverse x can be drawn in the similar way, and this is the graph of the y is equal to tan inverse x. Now come to our next section, next topic, that is limits. So if you have given a function fx, and this function is said to have a limit when tend to a limit l, that is the function is said to have a limit l, or it tends to a limit l when x is tends to a, that is the value of x is just close to a, and for a given positive real number epsilon greater than 0, and there should be a positive number delta such that mod of fx minus l is less than epsilon, where 0 less than x minus a less than delta. This is the definition of limit. That means if you have given a function fx, and that function should have a limit which is close to l for the value of x, and in such a way that the value of x is very close to a, and in this case it should be also a positive, and if for a given positive real number you have if you consider another real positive real number epsilon greater than 0, in that case mod of fx minus l should less than epsilon, and in this case you should one condition is there, that is 0 less than mod x minus l less than delta. Okay. And in mathematically you can represent this as limit limit x tends to a fx that is equal to l, and if x is a number less than a. So if you observe that x is a number, x is obviously a number, and f is a number which is less than a but very close to it, so very close to it, then the corresponding limit is called the left hand limit. And the left hand limit, when x is less than, just less than a but very close to it, then can be represented as limit x tends to minus fx. Okay, and similar, in the similar way, if x has a value which is just greater than a but very close to it, then the limit is said to be a right hand limit. And the right hand limit is can be represented by limit x tends to a plus then fx. And if you have given a function, and then the function should have a value, or the function should be finite if the for the function can exist if the left hand limit and the right hand limit both exist and are equal. So there are two conditions for a given function to have certain limit. The number one condition is the left and right should be left and right and right and right both should exist. Number one, and number two is they should be equal. So these are the necessary and required condition for a function to have some limit. So this is done here, this is written here for the necessary and essential or required condition for existence of the limit of a function, that is limit x tends to fx is there. If however these two limits, that is left hand limit and the right hand limits, are not equal, then the limit x tends to fx does not exist. So you should remember this, and obviously you should also remember that these values, that is a limit x tends to a minus f, is that is left hand limit, and also the right hand limit should be finite. That is, for a certain value of x they should have some definite value. And if however any one of them is not finite, that is they should not have definite value for a limit for a certain value of a x tends to a, then then the limit should also not exist. So we come here for three conditions. Number one condition is at left hand side and left hand limit and right hand limit should be finite. Any one of them, if any one of them is not finite, then the limit does not exist. Number two is they should be equal. If they are not equal, then the limit should not exist. And if however also any one of these two side limit is not defined, so that is the wall conditions. Okay, now come to some examples. Here are some examples show that limit x tends to 0 mod x by x does not exist. So we have to prove it where this limit actually does not exist. So you know the knowledge, you know that the given function, so just write here the given function y is equal to fx, that is equal to mod x by x, and you know that this mod x will be equal to x when x is greater than 0, and it is negative of minus x when x is less than 0. So you know from the property of modulus of x. So now you can write fx is equal to x by, that is mod x, so mod x can be written as x when x is greater than 0, so x by x, that is equal to 1 for x is greater than 0, and that is equal to x by minus x. So here the minus x should be here. So minus x by x, that is equal to minus 1. So for less than x less than 0. So now the left hand limit, what was the from the definition of left hand limit? We know that limit x tends to 0 minus, because we are here we are here to test the function if the function has if the function is the limit of the function does exist. We are checking it, we are testing it. So for that case, around the point O, so we are testing here the existence of the limit of fx around 0. So we are writing here limit x tends to 0 minus fx. This is the left hand limit, that is equal to limit x tends to 0 minus mod x by x. You know the value of mod x by x from here, that is equal to 1. So it is minus 1. This is finite. So this is finite from here. This is finite. Similarly, the right hand limit is here. So x tends to 0 plus fx, and you know that that value was plus 1. So this is plus 1. So although these are finite, but these are not equal. So the another necessary condition was that these two left hand limit and the right hand limit should be equal. So since they are not equal, so this limit does not exist. That is, the limit x tends to 0 mod x by x does not exist. Now the another one is the second another example is limit x tends to, you have to show that the limit x tends to 1 by x does not exist. So you have to obtain, you have to employ the same process. So same method. So here write y is equal to sin x 1 by sin x. Now the left hand limit is limit x tends to 0 minus fx. Now you replace just x by 0 minus h, such that when x tends to 0 then h tends to 0. So this limit can be represented now as the limit x tends to 0 minus sin x. You know that phi fx is sin x, that is equal to limit h tends to 0 sin, then this can be written then these x to be replaced by 0 minus x, that is here 1 by 0 minus h, that is equal to limit h tends to do sin 1 by h. So that is equal to minus 1 by h. So that is equal to minus limit h tends to 0 sin 1 by h, and from here you know that if you use the value of h is equal to 0, then it is sin infinity. So which is therefore the function, given function y is equal to sin 1 by x is not definite. It is not definite. It has not finite value. So the given function does not exist. Number 3 is here, limit x tends to 0 x plus mod x by x, and you have to prove it that this limit does not exist. To do that, you just write the equation, that is let y is equal to fx, and that is equal to x plus mod x by x. So now just here consider two cases. Now fx can be written as x since it is mod x, so x minus x by x for x less than 0, you know it, and it can also be written as x plus x by x when x is greater than 0. Now the left hand limit, just calculate the left hand limit, x tends to 0 minus fx. Okay, that is equal to limit x tends to 0 minus, and from here right, this is for x less than 0, so x minus x by x. So this x will cancel each other, so that is equal to 0. And the right hand limit on the other hand, the right hand limit is x, limit x tends to 0 plus fx, that is equal to limit x tends to 0 plus then this value x plus x by x, that is equal to 2. So this is finite, this is also finite. No, so both of left hand limit and right hand limit are finite but are not equal, they are unequal. So the given limit does not exist. Number 4 is here, value of limit x tends to 0. So find the value of limit x tends to 0 root to 1 plus x by x minus root 1 plus x minus 1 by x. So here is the calculation is there. Just you go through this, you will finally find out that limit x tends to 0 root over 1 plus x minus 1 by x is equal to half. Just go through this. You should know, you will not suffer any problem to understand this. Now the another one is here, limit x tends to a, and then x to the power n minus a to the power n by x minus a. You have to find out the value of this limit. So just you replace h by x minus a. Then when x from here x is equal to h plus a, you can write this, and x tends to 0, then h tends to if x tends to a, then h tends to be 0. So from here you can write this limit, a limit x tends to a, x to this is equal to limit x tends to 0 here, because in this case x should be replaced by x plus a, that is here x to the power n means x h plus a to the power n, then a to the power minus n, then h plus a here because x is here, and then minus a. So from here limit h tends to 0, and this is the first term and this is the second term, and this a will cancel each other. So actually here a to the power n is taken as common term, then 1 plus h by a to the power n, then minus a to the power n by h. And you know the binomial expansion of this such term, 1 plus x to the power n is equal to this is the similar term, that is 1 plus x to the power n. So here x is equal to h by a. So this can be written as 1 plus first x, that means nx, that means n into the power is n, then h by a, plus then n into n minus 1 by 2 factorial actually here h is equal by a square plus etc. So now this term, so the limit, this limit, so this line, this term is written here. This can be written as a to the power n is taken here. Limit h tends to 0. Then 1 plus h by a to the power n minus 1 by h. So that is equal to a to the power n. Limit h tends to 0. And it is the, this is the binomial expansion of this term, and then minus 1 by h. And just go through some simplification, and that finally will give you a to the power n. Limit h tends to 0. 1 plus n minus 1, then 2 factorial over 1 into 2 you can write in this way, into h by a plus other terms and then n by a, and from here this, and finally you obtain the, using the value of h is equal to 0, the value of the given limit as n a to the power n minus 1. So the limit is equal to this. Now come to another example. This is here limit x tends to 0, sine x by x. So here also just you think of the substitution of x is equal to 0 minus x, and in this case if x tends to 0, then h tends 0 0 minus, then h tends to 0, then the left hand limit x tends to 0 minus sine x by x can be written in this way. Limit h tends to 0, sine 0 minus h by 0 minus h, that is equal to, here from here sine minus h and from here minus h, that will cancel each other, and this is sine h by h. And just here you just expand the series of sine h, that is equal to, or sine x, that is equal to h minus h cube by 3 factorial plus h to the 5 by 5 factorial, and all other terms that are written here, then by h. Just simplify it, then h tends to 0, 1 minus h square 3 factorial plus h to the 4 by 5 factorial, and all other terms, that is equal to, just value, use the value of h, that is equal to 1. So limit x tends to 0 minus sine x by x is equal to 1. So it is finite. And in the similar way, you can, if you wish to, you can find out the value of right hand limit, then that will also be equal to this. So since line and right hand limits are equal, so this limit exists and the value of the limit is 1. And that is also here, that is also done here. So the limit, actually limit x tends to sine x by x is equal to 1. Now another one is, show that limit theta tends to 0, tan theta by theta is equal to 1. It is not very difficult to prove it, just do it yourself. Now another one is limit x tends to 0, tan ax by sine bx, that is equal to a by b. You have to prove it, and this is done here. Just calculate yourself. You can prove it. You can able to prove it. Another example is here, this one and this one. Just go through these and just calculate yourself. Just calculate. You will understand, and you know actually how to calculate the limits of a function in this class, so it will not very difficult to you to calculate this. So just calculate yourself. Now I am leaving this for you. Now theorems of limits, you already have basic idea about limits in your previous class, that is in your previous classes 12 class, so HS standard. So here are some, I have summarized some theorems on limits. Just go through this. You need not to just go through this, and if you have any problem where this kind of form of limits will appear, you should employ these theorems. So these are theorems and important formula for limits. Here are also and just I have summarized also here important value of limits of uh, uh, some some quantities that are written here. Just go through this, and here are also using this kind of, using these theorems or these important limits, you can prove this kind of, you can find out the value of this limit, that x tends to 0, 1 minus cos x by x square. It is also calculated here. Just go through this, go through this. It should not be very difficult to understand. And I must so this is the usual method, or the usual method to find out the value of a limit. So here an example is just I am dealing with this, and it will take very not very much more time, because just see this limit, and first you can use the value of x as 0, and just write, since the limit is x tends to 0, then just use the value, or just substitute the value of x in this expression. If it is not equal to 0, or it is finite, sorry, if it is a finite one, then you can directly use the value of x. If it is not finite, it becomes indefinite, then you have to use L'Hospital's rule or any other things. I am not dealing with L'Hospital's rules. You just find out some examples using L'Hospital's rules. So in this case, since x is equal, if you put the value of x, this value is finite, just directly use the value of x. So that will provide you minus 1/4. So this is the very basic idea about a limit and plotting of functions, and you need to practice more and more using some problems related to limits and also plot the functions. Then everything will be very clear to you and very easier to you.